So I will be doing part C from problem 4 of test 3, where the initial state of the system of the electron and positron when they're 1 times 10 to the negative 14 meters apart, and then the final state is when they are infinitely far away, like super far away from each other. So to begin with, you can look at the initial state and say when they're this far apart, you know that they do have to have some potential energy. So you cannot start at 0. So you can automatically eliminate choices 4 and 6. So then you can look at the final state for the potential energy and say when they're super far away from each other, even though the electron and positron are opposite signs and they do attract each other, when they're that far away, it doesn't really matter. So you can say that or it doesn't really matter, and that the potential energy is 0 at that point. So because when they're super far away, it doesn't matter what you have on top of the equation. If you have infinity, it just goes to 0. So you can draw the sloping line. It starts from a negative number and then goes to 0, because your equation for u is q1 and then q2 over like r. So when you have two opposite signs, u will be negative. So that's why it starts down below and then goes to 0. So as for kinetic energy, you know from part A of problem 4 that the electron and positron do initially have kinetic energy, and that kinetic energy is positive. So you can start drawing the kinetic energy. And then from part B of the problem, you know that the electron and positron still have kinetic energy when they're infinitely far away. And the kinetic energy they have is still positive, though it is smaller than the energy in part A. So you can draw it sloping like so. And then to draw E, you can plug in the equation, I guess, and say E equals K plus U. And then when U goes to 0, it's just E equals K. So you draw it not quite touching, but it'll slope to this point. And that's the problem. So your answer would be 3.